Okay ji. Uh, so guys, now we are going to solve the problem number 8 that says consider the undirected graph. So now we are going to we are considering the undirected graph, that is G, and that is equals to V comma E, where V is the set of nodes. So in this set we have to construct an undirected graph where the G graph is equals to V comma E, where V is the set of nodes, and nodes are like 1 comma 2 comma 1 comma 2 comma 3 comma 4. So there are the 4 nodes, and number of edges are given like these. If you can see here, the number of edges are, so number of nodes were 1 comma 2 comma 3 comma 4, and number of edges are 1 to 2, 2 to 3, 1 to 3, 2 to 4, and 1 to 4. So number of edges is a set that contain the edge 1 to 2 and the edge 2 to 3, the edge 1 to 3, the edge 2 to 4, the edge 1 to 4. So basically we have to construct an undirected what we can say the graph. So a graph is a kind of order pair of two things, or it's a kind of a tuple that contains V or E, where V are the number of nodes in the graph and E is the number of edges on the graph. Are the number of edges in the graph. For example, now it says you have to construct a graph. For example, there are the 4 nodes. I'll be considering that this is node 1, this is node 2, and this is node 3, node 4. Let's say like this. So this is node 1, this is node 2, this is node 3, this is node 4. So we have to construct the graph from 1 to 2, means 1 to 2, then 2 to 3, and we will construct from 2 to 3, and then is 1 to 3, means it would be kind of 1 to 3, or it can be the very straight line 1 to 3, and then 2 to 4 means this 2 to 4, and then 1 to 4 means this would be the graph, the what we can say the node from 1 to 4. This is not the node, but this shows the direct transition. So we can say now this is the edge, and this edge would be called as 1 comma 2, this edge would be called as a 2 comma 4, and this edge would be called as 1 comma 4, this edge would be called as 1 comma 4, and this edge 1 comma 3, and this edge would be called as 2 comma 3. So this is the graph. That problem was saying that here, if you look over there, consider the undirected graph. This is a G, where V is the set of nodes like 1 2 3 4, and E is the set of edges, and this we have drawn. Draw the graph G. What are the degrees of each node? Now we have to find out the degrees of each node. Indicate a path from node 3 to node 4 on your drawing of G. So then now two things are remaining. What are the degrees of each node? So if we talk about the degree is the number of relations with other nodes. If we consider this one node, so degree of 1 means degree of node 1. Here you can see 1 has a relation with 4, means 1 is related to 4. It is called as a degree 1. Then 1 is connected to 3. This would be the 1 to 3, degree 1, degree 2, and another degree is 1 to 2, means 1 to 2. This is the degree, another degree. So total degrees of 1 are 3. Now degrees of 2, if we find out the degrees of 2, if we think that if we see here 2 is connected with 1, means 2 to 1, then 2 to 4, 2 to 4, then 2 to 3. So total degree is 3 over here also. If we talk about the degrees of 3, so degrees of 3 are like 3 is connected with 2, means 3 to 2, 3 to 1. Yes, only 2 degrees are, so we can say the degree of 3 is 2, degrees of 2 is 3, degree of 1 is 3. So now degree of 1 is done, degree of 2 is done, degree of 3 is done. Now we are going to find out the degree of 4. So degree means to how many number of edges, nodes, a node is connected. So node 4 has connections with 4, means 4 to 1, 4 to 1, then 4 to 2 only. Yes, so means total 2 degrees. So in this nutshell we would say degree of 1 plus degree of 2 plus degree of 3 plus degree of 4 is equal to degree of 1 is 3 plus degree of 2 is 3 plus degree of 3 is 2, degree of 3 is 2 plus degree of 4 is also 2. If we count them all, 3 plus 3 6 plus 2 8 plus 2 is equal to 10. So whole degree of this whole the graph is 10. We can also find out this by in a shortcut way, like how many edges are there, 1 2 3 4 5. So total edges are 5. We would multiply by 5 with 2 and we would get 10. So from here we can also find out the total degrees, but this shows the total degrees, and these are all the phenomena we are finding out the degrees of each and individual nodes. Now the third part of the question says indicate a path from node 3 to node 4 on your drawing. Means node 3 to node 4. We have to find out the path from node 3 to node 4. Okay, this is node 3. This is node 3 and we have to find out the path from node 3 to 4. If you see here, we can go from 3 to 1, means if we find out a path 1, that is if I can go from 3 to 1, then I can directly go 1 to 4. This is the simple path 1. Other paths can also be there. For example, if I want to, if I can go from 3 to 2, then I can go from 2 to 4. This is the path 2. That can also be your answer. Okay, if I want to go, another path could be I can go from 3 to 2, then from 2 to 1, then 1 to 4. This would be the longest path, but it can be the path number 3. So this is the whole answer of this question. That problem was problem number 0.8 related to the construction of the graph. So that's the answer.